Okay, Chloe, Avelie's advocating for you. She said that you had a question on 4-5 homework, number 40, graphing this guy, right? Are we graphing it? Yes? Okay, and then we are going to bump to like 4-6 notes, but we also need your unit circle that has all this graphs on it because we're going to add stuff to it, okay? So there is that. So number 40 first on 4-5 homework assignment. Here we go. We only have a couple things, okay? When you guys go to graph this, I still write out my amplitude, my period, my phase shift, my vertical shift, right? Okay. This one is A, this one is B, this one is C, this one is D, right? Okay. We only have which two? We only have an A and we only have a C. So the period is still going to be 2 pi, right? There's no vertical shift. And that's all we have, right? So our amplitude now is 4, right? So he's taller than normal. And then how do you find the phase shift? Period is like 2 pi over B, right? To find the period. But phase shift is what? Negative C over B. Okay, now, we actually do have a B value. What is the B value right here? 1, right? Okay, so if we do negative C over B, it would be negative pi over 2 divided by 1, which is negative pi over 2. So that means you're going to the left pi over 2. Okay. All right, and we're graphing sine, right? Okay, so since we're going to the left, I'm going to leave a little bit of space right there for him to go to the left. Okay. All right, here we go. We are going up to 4 and down to negative 4. So I'm going to go 4 here and negative 4 here. And normally we go out to 2 pi, right? This middle guy would be pi. This guy right here and this guy right here. What's this marking? Like, where is this guy located at? Pi over 2. And then this guy's like 3 pi over 2, whatever, right? Okay, so the deal here is we're going up to 4 and we're going down to negative 4. So I'm going to do my little dotted line thing, whatever, right? Okay, and we are going left pi over 2. Okay, pi over 2 is this far. Negative pi over 2, and that's where we're going to start him, okay? Now, we still want the period to be 2 pi long, but where's he going to end at? If we do that. If we go left pi over 2, he's not going to end right here. He's going to end at 3 pi over 2, right? And then that's where he will bounce in between, right? So sine starts down here at 0. He's going to bump up, down, down, back up, and it's going to look like this. That's what sine would be. Something like that. Does that make sense? That is number 40. Just shifted over and a little bit taller. Yeah. Warmer, warmer, warmer. Just hit it 3 times and it'll maybe go.
It's freezing. No, it's not. It's perfect.
Nice. Oh, I should have you guys type out my food things. My food things.
No.
No, he only got like table 3 done.
Yeah, table 4 still needs.
Okay, good? Anything else besides number 40? No, that's good? Okay. All right, you guys have your unit circle. We're going to write on the back of him some other cheat sheet, guys. Okay, so your pink sheet that we did this on, we're going to add to him. Okay? Yeah. I'm going to erase. Oh, what are we doing? There we go. Okay. We're starting 4-6, yes. But we're starting with your unit circle, the back side of him where you have, do you have 3 graphs already done? No, you only have 2. You only have 2 graphs done. So we're going to do the other trig functions. Like the other 4 trig functions, actually. We'll just do secant and cosecant today. Okay? Okay. Good? Are we ready? We got our stuff? Okay, here we go. All right, sine and cosine. You guys have those graphed already on the back side of your unit circle. You don't have a third one down here. That should be left for tangent. I have something down here, but that's not supposed to be there. You guys have some space down there for tangent. We'll add him tomorrow. We're not going to do the tangent part until tomorrow. But we're going to do secant and cosecant. Which one goes with sine? cosecant. So I'm going to put y equals CSC of x. Cosecant. Okay? All right, I'm going to graph him out like this. And I'm going to graph him like this. Okay? This is your y-axis. This is your x in terms of radians. Okay? All of the things, right? Cosecant. Okay. All right. And cosecant is very easy to graph if you know how to graph sine. That's all. No. So what you're going to do is I'm going to mark 1 and negative. Well, I'm going to mark 1 and negative 1 right here and right here. This is 1. This is negative 1. Okay. He goes to 2 pi over here. Okay. If sine's period is 2 pi, cosecant's period is also 2 pi. Okay. So put him down there. 2 pi. What's up?
Hey, just to let you know, Miss Cleaver offered.
Oh, she did? Okay. Count me out.
Is that all right?
Yeah. Yes. If she wants to, yeah, that would be awesome. Yeah. Because I'm like, oh, I don't know. Yeah. Okay. Perfect. Count me out. I'll take it in 5 years from now.
Wednesday, the last 10 minutes of school. School. Okay? Yes. There's a lot going on. So that's the only opportunity to have. How do I do this?
Remington,
What?
go show her quick what you're doing. Okay. All right. So there he is, right? All right. Here's the deal. Cosecant. Whenever you're graphing cosecant, we are going to graph sine first. Yep, we're going to graph sine first. Okay, so we're going to do like a little imaginary like sine. Oh, sine is going to graph like this. So my 5 dots, this dot, this dot, this dot, this dot, this dot. This is what sine is going to look like. So I'm going to do a little imaginary sine, blah, blah, blah. Oh, gosh. Oh, gosh. Let me move my dot over. He goes right here. Like, do a little bit better of a job. Just make him either really light or like dotted. Okay, and he going to go like that. Okay, like that. That's what sine looks like. Cosecant. Are you ready? Cosecant is going to have vertical asymptotes. Okay, and here's what cosecant looks like. He has a vertical asymptote. I'm going to make these thick. Vertical asymptotes here and here
Are we gonna graph the
and here.
vertical asymptotes every time we graph?
Yes, yes. The vertical asymptotes should be on there. Okay. Those need to be put into place. Okay. Now, where do the vertical asymptotes live?
0, pi,
Wherever sine crosses the
x-axis.
x-axis, but what if we move them up or down? It's wherever sine crosses the midline, right? Okay, so it's wherever he touches the middle line, which for now is the x-axis. If we move him up, it'll be where he touches the x-axis. Okay, here's what cosecant looks like. Ready? Blink and you miss it. Cosecant is this guy. And this, oh gosh, I have a like break in my computer there. And this guy, okay? He is like little parabolas that come and kiss sine. Right there, they touch at that one little place, and then he's like bound by the vertical asymptotes, okay, on either side. That's just how he goes. Yep, yep, yep. That's how he works. So he is bounded by, and he will continue on forever, right? Like he continues to go, like sine continues to go this way, right? So he'll be over here as well and over here as well, right? He'll just look like the little loop-de-doos, okay? And I'll have vertical asymptotes everywhere, but it's just bound by those vertical asymptotes. It looks like a parabola. He just comes down and he touches at this one point right here, right? Okay, so let's talk about like domain and range, right? Okay? As far as domain goes, do you have room to put domain and range? Domain. Let's put him right here. Domain. He's going to go left and right forever, right? Except he won't touch. What will he not touch? Left and right.
0, pi, 2, pi.
He won't touch wherever these vertical asymptotes are. So how do I write that for domain? I'm going to say all reals except
Ask her about it. Yeah. She messed
all
it up.
intervals of pi over 2. Or all intervals of pi. So I'm going to say pi k. All right. All reals except for pi k. K meaning you can plug any number in for. So like 1 pi or 2 pi or 3 pi or 4 pi or 5 pi. Any intervals of pi k, right, he will not touch. Okay.
What is
Now.
the yellow line?
That is what cosecant is.
Oh.
Cosecant is the yellow. Sine is that little dotted line. Cosecants are the little parabolas that branch off of sine. They come and they touch at one place, but that's what cosecant is, the yellow
So it
part.
starts up at 2.
No, he doesn't start at 2. He goes on forever up this way, right? Like the arrows go that direction.
So
The lowest he goes is 1 right there. Okay? Yep. Yep. He'll just touch any of those highs and low points. He'll just like kiss them, and then he'll go forever as a parabola down the other way. Okay? Range is up and down. Will he go up forever? Yes, he will go down forever. Yes. But he won't touch anywhere in between here because that's where sine lives. That's not cosecant land, that's sine land, right? So the range is going to be from what to what?
left to right.
Let's talk down. Will he go down forever? He will go from negative infinity until he gets to how far?
Sorry.
Negative infinity until he gets up to here, which is where? Negative 1. Will he touch negative 1?
Or yes.
Yes, he will. He'll touch negative 1. Okay? Unioned with, he doesn't live in here. Okay? What's the next highest he goes? He'll touch at 1, and he will go to infinity. Do you see how those two little loops, that's the range? Okay? Up and down. He'll go down forever, up until he gets to negative 1. He'll stop, and he won't live in here because that's sine land, right? And then he'll start there, and he'll go up forever. Okay? So that's domain and range.
So about the bond
Got it?
tables, I don't know where to find the sheet where you can add like all the names and features. So I don't know where that-
Oh, gotcha. Okay, that's fine. He's on a, yeah. I'll get him back up again.
Sorry, I'm still thinking. You can put me down for Wednesday.
For Wednesday?
19.
You don't have to commit right now.
Yeah, I can.
Okay.
Because I'm trying to.
What is that?
Remember, so Wednesday and Thursday.
Wednesday and Thursday. Okay, y equals cosine is secant of x. What do you think the period of secant is going to be? Probably 2 pi, because it's the same as cosine. Okay, now, guess what? If you can draw cosine, you can draw secant. Because it's going to be the same. All right, here we go. Whoop. Whoop. Y, here's my x-axis in radians. Here is where 2 pi lives. Halvesies would be pi. Halvesies would be pi over 2. And 3 pi over 2. And I'm going to put my 1. I'm going to put my negative 1. Okay.
Not touching.
What?
Because we inserted a tape, and then we had to like put more, and then it like deleted what was up above.
We'll fix him. It'll be fine.
I'm not touching.
Okay.
And then
Undo.
everything is
Undo is my friend. Undo is my friend. It's okay.
Remington knows like
This is not true. This is not true.
It's
What
okay.
did I do?
You know, that sounds like a good job for like Lauren and Macy to do.
What?
7th period. You betcha.
I'm not
All right.
yelling.
Okay.
Let's do a quiet
All right. Graphing. Cosine. Where does cosine start?
This is elementary.
Where does the period, the first period of cosine start? At 1, and then he goes down, and then he goes down, and then he comes back up, and comes back up, and I'm going to do him in like little dotted lines so we can see him, but he's like not there, right? Okay. So he does one of these. This is what sine looks, or cosine looks like. Okay. Now, secant is exactly the same thing as cosecant. Where do my vertical asymptotes here live?
Vertical asymptote.
Pi over 2, pi over 2.
Pi over 2 and 3 pi over 2.
The only reason
Right?
I know that is because of Jack's papers.
Because, where does he touch? It's where cosine touches the middle line, right? The middle line here, it's where he crosses through, so we know we have a vertical asymptote there and there, right? Okay? And then, what does cosecant look like?
It's like a half a parabola.
It's like a half a parabola here, right?
Yeah.
And it's like a whole parabola here. And it's like a half of a parabola here. Now, is it truly half of a parabola?
No.
No, because if he would continue on forever, he would be a full, complete parabola. But the first period of cosine looks like a half, a whole, and a half, right? Does that make sense? It's just because he shifted over. So he looks kind of like a sad face, right? He's got like an eyeball here and an eyeball here, and he's frowny. Frowny face. Like Megan does the best. I love it.
So then I laugh and then it goes away.
I don't know how you do that. I don't know how you do that. I can't. I know. I can't do it. I don't know how Megan can do it. Okay. All right. So let's talk domain and range. Domain and range. Okay.
I'm not doing that anymore.
I'm better.
All right. Domain is left and right.
I'm better.
La, 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 la. Domain left and right. He will go to the left forever. He will go to the right forever. But he is all reals except for. Except for what?
Domain is X, right? Like left, right? No?
Why'd you say that like Spanish person?
What?
Okay.
Like Spanish?
Domain is X,
Everything
no?
except pi over 2 and 3.
Yep.
So intervals of pi over 2.
Not because pi is an interval of pi over 2. That's the only problem.
No, I don't know.
Okay, so he will not touch. The first place he doesn't touch is where? He doesn't touch pi over 2.
Intervals of pi over 2 and pi over 3.
Plus pi k. Here's how this works. All right, are we utterly confused?
Wait, do we write that?
Yep.
Pi K. Pi.
He will touch everywhere except for those vertical asymptotes, true? The first vertical asymptote he does not touch, right, is at pi over 2. But it's not every interval for pi over 2 because the next interval of pi over 2 would be at pi, right? And he touches at pi, right? So it's pi over 2 plus, what's the distance from here to here?
Half pi to. No?
From here to here is pi, right? So at pi over 2 plus another pi he won't touch. Plus another pi he won't touch. Plus another pi over he won't touch. That's why we say pi over 2 is where he doesn't touch the first time, plus all intervals of pi k after that, right? So here, and then the next interval from pi k, and the next interval of pi k, and the next interval of pi k, whatever. He won't touch there. All right, range. Let me move the range down just a bit. Will he go up and down forever? Yes, except he will not touch. He will not touch cosine land because cosine land lives there, right? So let's talk about down first. Negative infinity up to
Negative 1.
-1.
Bracket.
Bracket. Union with
Bracket 1.
bracket 1 to.
Infinity.
So is that the same as cosecant? Yeah. You betcha. Beautiful. Awesome. Awesome. Okay. Alrighty. There you go. Domain and range. All the things. Okay. Let's do example 1.
Where did that come from?
Let's do example 1.
And then we'll be done.
Example 1 is actually on the second page. So we've done all this stuff. We know what's going on here. Okay. Example 1 and example 2. We'll do those two and then we'll stop. Okay. Before we get to tangent. All right. Here we go. Graphing a variation of secant. Okay. Instead of graphing secant, instead we're going to graph what? Cosine, right? 3 cosine of 2x. All right. The 3 is which letter? A, B, C, or D?
A.
A. The 2 is B. And so that affects the,
Height and.
we have amplitude, we have period, we have phase shift, and we have vertical shift. Okay? Which 2 do we not have?
The last one.
We don't have phase shift, we don't have vertical shift. That's awesome. Okay, amplitude is how far?
3.
3. Period is 2 pi divided by B, which is 2. So my period now is pi. So it is smaller than it was before, right?
C.
Yeah. Okay, so let's graph him.
It's C.
There he is. Something like that, right? Okay, the amplitude is 3. All right, we're graphing cosine, right? We're graphing this guy right here. Okay, but leave enough room so that we can do the little parabolas off of him. So we have 3 and we have -3, right? Okay, but instead of him going to 2 pi here, right, he's only going to pi. And what's halfway in between 0 and pi?
Pi over 2.
Pi over 2. Do you know what these little guys? Oh gosh, I need to make him smaller.
Pi over 4.
He is pi over 4 and
3 pi over 4.
I don't know why I put pi over 3. Pi over 4 and 3 pi over 4. Okay, so he's going to live like right here, cosine is.
Why is it cosine?
Okay, because instead of graphing secant, we graph cosine first, okay? So cosine starts up at 3, right? He goes like this, so he's gonna do like one of these. Okay, like that, right? And that's what he looks like, okay? Where are my vertical asymptotes gonna live?
Pi over 4.
Pi over 4 and 3 pi over 4. And then I do my little parabola things, right? So he's halvesies here, he's a whole one here, and he's a half one here, and that is what secant is. So final answer is the yellow one, and not the black one, or the green one. I guess the green one's part of the yellow one. Okay, weird stuff. If you know how to graph cosine, you know how to graph
I
secant.
feel like I could have done that without the
Yeah,
cosine. But
you think so? Yeah, probably.
I'd
You
rather
probably
do
could have,
it Just secant, no cosine.
right? Okay, sure,
It
that's fine.
messes me up.
Okay, all right, now these guys, oofta. To graph cosecant, we instead graph sine x minus pi over 4. This is what I'm going to graph to begin with, plus 3, okay? All right, so we've got amplitude, we've got period, we've got phase shift, we've got vertical shift. Let's figure out what we have. Do we have an A?
it's 1.
No, A is 1, right? Okay, do we have a B?
No.
B is 1, right? So that means amplitude is,
5.
nope, amplitude is
Wait.
1,
Oh, I thought
period.
it was
Period, since this is 1, this is 2 pi divided by 1, or just it stays 2 pi for the period, right? Okay, now we have a C. C is negative pi over 4. How do you find phase shift? What's the formula for it? Phase shift.
Did we write it down for the one up there? Did I just miss it?
We didn't have a phase shift.
Oh, okay.
Yeah. What's the formula for phase shift?
Negative.
Negative C over B. Okay, what's the C part?
Pi over 4.
Negative pi over 4, because negative C, over, what's the B?
4 over 1.
Over 1, which means
Pi over
he is positive pi over 4. Is that to the left or to the right?
Right.
To the right. If you look in the equation, minus means right, correct? Okay, vertical shift is
Up 3.
up 3. Oh my good golly. Okay, here we go.
Wait, I have an idea.
You have an idea.
I
Okay.
mean, shut up.
I mean,
All right, we're going up 3, so I'm going to go like this. Boop, because we're going up 3. All right, up 3. 1, 2, 3. My new middle line is at 3. Oofda. There he is. There's my middle line. Okay? And then his amplitude, this is at 3. His amplitude is
Up 1 down.
1, so I'm going to go up to 4 and down to 2. And there's my other little guy, right? Okay? All right. Let's do this. The period is still 2 pi. So 2 pi is here. Oh, gosh. Pi is here. This guy right here, what's the little halvesy mark there? Pi over 2 and
Pi over 2.
3 pi over 2. Okay, except we're going to start where?
At
What is
1.
this?
We start at, I got to start my cycle at
Oh, we have to move
pi over 4. How far is pi over 4? How far is pi over 4?
between pi over 2 and 0.
Yeah, right here. I'm going to start him here, right? So he's going to start here, right? That's not a vertical asymptote. That's kind of confusing now. So he starts there, and where does he end then?
2 and 1/4 pi.
Yeah, so like over here, like at a halvesy mark over here, right? That's where he's going to end, okay? And we are graphing which one? Sine? Oh, Lord. We're graphing sine. Where does sine start? In the middle? He goes, oh, gosh. Oh,
It's
gosh.
going to end at 9.
Oh, gosh. He's going to be up right here. He's going to be to the middle again here. He's going to be down right here and back up again. So he's going to look like this.
Guys, this is not fun.
This is not nice.
Probably because it's
Dare I
not.
say?
Wait, that's not even the actual.
That's sine. Ugh, that's just sine.
Basically just put little.
So where are his vase at?
The
4
top one and the low one.
and the
Oh.
other one.
His vase are in the middle, where he touches the middle guy. Because he has to kiss the top one, top and the bottom. Yeah? So he's kissing here, and he's kissing here. He kisses the top and the bottom, and then in the middle is where his vase are. Oh boy, that's a lot.
I did not enjoy that.
That was not a fun one. Just because he was moved pi over 4, that made everything disgusting. Right?
All done.
Oh my god.
Gross. Yes, ma'am.
Can we not learn tangent and cotangent?
No, we're not going to do tangent and cotangent today.
Because my brain would not.
I would, though, grab your homework assignment and start graphing as many of these as you can so while it's still in your brain.
Is the homework assignment?
What? Oh, what is the homework assignment? That's a good question.
There's a lot.
There is a lot.
I did that one.
Page.
20, 20.
Okay, hold on. Page what? Page what?
Okay, so we're just missing
562.
public.
562, thank you.
18,
18,
20,
20,
22,
22,
36,
36,
44,
44,
50,
50,
60.
60. Oh, that's not that bad.
It's-
Where do we stop? Tangent starts at which one?
Starts at 39, so we can.
Okay, so you can do the first four.
Look how
There you
far I
go.
got on the economics paper.
There you go. You can do the first four. Okay?
I did that far, and I got
All
to-
right,
I
does
got
that
to
sound okay?
3 and 6, and I'm
Good.
like,
Anything else for the good of the cause? Do we have to tell Chloe anything?
Hello.
I hope you're having fun, Chloe.
Her to
I
make
know.
sure she doesn't pee the bed.
What are you
Bro,
talking
what
about?
the-
She has an issue with peeing the bed.
Tell her.
Oh, okay. All right. Okay.
Don't be
I
the
don't.
bed.
Okay. All right. Okay. Bye, Chloe.